Hello everyone. I'm Teyvonia. I'm a robotics engineer who specializes in machine vision and more broadly perception. The last time I gave a lightning talk, I presented this document scanner app which I built just to illustrate how you can integrate computer vision into your own applications. Today I want to talk a bit about augmented reality and specifically a platform I use or you could use to build your own AR applications. So I'm going to demo scenes from two AR apps. The first is an augmented coloring book. So I essentially created a coloring page, which starts out colorless. Then I color in the page. Then I use a texture mapping algorithm to essentially capture the colors from the objects on the page to their 3D models. So the whole idea behind these augmented reality coloring books is to bring the scene to life. So I essentially added animated characters to make it more lively and fun. I'm sure we've all used static coloring pages or books back in the day, and they were not as fun. So like, kids will adults love this stuff too. So the image target in this scene, the coloring page and stuff, and I'll talk more about that. The second is a scene from just a simple game. In this example, a magazine cover serves as So these are just like two examples. Like you could build whatever you want. The idea is that you want to bring whatever to life right in front of you. Okay, so I used a platform called Teyvonia and Unity to build those AR apps. Teyvonia is a cross-platform augmented reality application or SDK that you can use to build these AR apps for mobile devices or head-mounted devices such as HoloLens. It uses advanced computer vision algorithm to do detection and tracking in real time, so you can orient yourself with respect to the image targets and project these 2D scenes onto your target. There's an API for C++, Java, and Unity. What this means is you can do native development for Android and iOS, as well as do app development in Unity, which you can then easily deploy your AR apps onto these mobile devices. So if you're a game developer, you probably are already familiar with Unity, which is a popular game development engine where you can use to develop 2D and 3D games for different types of devices, and the main language they're used is C#. So I just wanted to give you an idea of how easy you can build your AR applications in Unity. So not the native development environment, but using Unity. So I just kind of created a video of this workflow. So here I just started a new Unity project, switched the platform to Android, enabled Teyvonia, deleted the main camera, added an augmented reality camera into the scene, imported Teyvonia assets, configured Teyvonia. Then there's also a Teyvonia development port, which you can use to manage your licenses, which you need to actually make your apps work. So I've copied the license into this application. There's also a target manager database. Here's the target is just a magazine cover. I download the database containing the image target. import that database into Unity. Then I add the image target from that database, and right now I'll essentially be projecting a barbarian model onto that magazine cover. Added a simple simulation, built, I guess I tested this with the camera attached to my laptop, build the package, copied the APK file to my phone, and voila, the Arabian is. Right, so what's inside Vuforia? So there are a lot of 2D and 3D targets you can use to do detection and tracking. Image targets are the simplest, and they are essentially what I used in the previous applications. In the coloring book example, the coloring pages are the targets. In the case of the game, the magazine cover served as the target. You can also use, if you have CAD models of your objects, you can also use those as targets. So using those, for instance, you can then, once they're detected, project useful information such as names of parts on your object, and then use them to kind of like see inside your model. So these are particularly useful in service or repair applications. If you don't have a CAD model of your object, you can use Vuforia's custom object scanning and tracking tool. So if you have like a toy car model at home, for instance, that you want to project objects on, you can use that. The smart terrain interface is something that they've included, which basically allows you to track multiple interesting targets and kind of build this really cool landscape right in front of you. There's also ground plane detection. So if you've played apps like Pokemon Go, ground plane detection is a key component in apps like those. There are virtual buttons which you can use to interact with the scene. There's video playback. So for instance, if you wanted to create an augmented reality greeting card and you wanted to project a video that you've recorded onto that card, you could insert video playback into that, and there's multiple target tracking. So Vuforia consists of a lot of components and algorithms, but you can also build your own AR applications from scratch. So I wanted to just give an overview of what the pipeline for a simple marker-based or augmented reality consists of. So first you select and define your marker, then you detect features in your image target. And features are just these salient points within the image, which you use for tracking. Once you have that database of your image target, as you're scanning your environment, trying to find that target, we do feature matching to determine whether or not your target is in that camera scene. And once you've detected enough similar features, you can assume that your pattern has been found. Then using those 2D correspondences, you then perform and 2D to 3D correspondences between the image target and the world object. We can do camera pose estimation, and I haven't included like all the formulas and algorithms because it's kind of involved, but it's a well-known problem. Once you have that, you can essentially project your 3D model onto your image plane. So this is just a simple example of a cube being projected into the scene, and the real purpose of the image target is to be able to localize yourself with respect to the marker. So figure out where the camera coordinate system is in relation to the marker coordinate system. And once you have that, you can essentially orient the object or the scene correctly with respect to your image target and move around. So in this example, I'm not using Vuforia, I'm using OpenCV and OpenGL. Every time I play a video, it's just Yes. So OpenCV is probably the most widely used computer vision library. So with OpenCV, even if you don't use it for augmented reality, there's like a ton of features you can use to make your apps more interesting or to incorporate computer vision components. So you can use multiple images to perform 3D reconstruction of a model. You can do people detection, object detection, which is a key component of the AR app, face detection, motion tracking, image segmentation. There are algorithms to detect text in real-world scenes, which are more challenging than detecting text on paper, and just tons of other features. And the reason I'm like highlighting OpenCV is because I studied computer vision in school, but you don't need to be a computer vision expert to basically make your apps interesting and incorporate computer vision components into them. You can kind of explore OpenCV and learn as you go. So yeah, questions. Yeah.
If you want to use OpenCV for Android, like is this a C++ library or are there Java bindings?
I forgot to mention, I think I had it up there. So there's an Android SDK called OpenCV for Android. So there's a Java API,
Okay.
and then using the NDK, you can also use C++ if you're also really that too. Yeah. So there for OpenCV, like outside of Android, there's Python. There's a Python API, Java, Objective-C, C++, just about, because it's like really widely used.
This is more of a comment than a question. We've all probably seen like the Cloud Vision APIs, like all the ML stuff that Google has, but I think a big drawback of those libraries is that, or the Google ones, is that the more powerful stuff is done all in the cloud. So you need a network connection. And you're also subject to whatever license terms they have. Where this runs, I assume, completely on device.
Right, exactly. Yeah, and it's really robust and really optimized for suite. So like even when you even with complicated applications and multi-target tracking, etc., you move seamlessly around the scene. So it's pretty good.
I also in that in iOS they release a new version for iOS. They don't use exactly the name.
Oh, ML.
Yeah, exactly. But you can do it on the device. You only have to include the models and exactly the models. They have a lot of pre-created models for identifying things, and you can add your own model. But the thing is that you have to accept their terms and conditions.
Alrighty. Yeah.
Sorry, I'm wondering if you had any experience with 3D reconstruction, and if you just speak more to how that would work.
And be able to, sorry?
If you had any experience using OpenCV with 3D reconstruction.
Yeah, I do.
And then, so, like, how does that kind of work? Do you have multiple phones connected, scanning the object? Or?
So I guess there are various ways you can do it, but you do need to essentially take multiple shots of an object from different angles in order to get a properly reconstructed object. Yeah. And there's also like, sorry, I mean there's sparse reconstruction which you can use for things like tracking like this. It doesn't need to be dense, and then dense reconstruction, which is more computationally expensive, and it's not something that can be easily done on a mobile device, for instance, just because of how computationally taxing the dense reconstruction is. Oh, sorry.
For instance, there is any hardware limitation to use this library. For example, in the Anderson group, is a minimum SDK or something like that.
Yeah, there's a minimum SDK. I can't remember the level, but yeah, there's definitely our API level. Yeah.
But in, it's another question. For example, in the case with OpenCV, some friend of mine used it, and I noticed their APK is really big because it gets a lot of space. With the framework that you were presenting, it also takes a lot of space.
Mhm. Yeah, I mean, it really depends on how much, like how many scenes you have in your application. Because like for this, it's really like only a few megabytes. But if you have like multiple scenes and really like massive games or applications, then it could get potentially large. Alright, thank you.